In Algebra 7, we're going to look at simultaneous equations where one is linear, this one here, and one is non-linear. And if you've done the circle, you can see that this is the equation of a circle. So what we do in all of these questions is we let x equal something in terms of y. So in this case, it's going to be 5 minus y. And then we sub in for x 5 minus y, and now we have an equation with just one unknown variable. So 5 minus y to be squared plus y squared is equal to 13. Simplifying this, we're going to get 25 minus 5y twice plus y squared, and then plus the other y squared, minus 13 equals 0. We can see this is going to be a quadratic. So we get 2y squared minus 10y plus 12 equals 0. And we can divide this by 2 to get y squared minus 5y plus 6 is equal to 0. Solving this, factorizing it first, we're going to get, you can see it's going to be 2 minuses. You can see it's going to be a 3 and a 2. If you can't, you need to go back and practice your junior cert algebra. So I'll just jump up the top here. That means that y is equal to 2 or 3. If x is equal to 5 minus y, x is equal to 5 minus 2, which is 3. And the other side of it is x is equal to 5 minus 3, which is equal to 2. So when x is 3, y is 2. Always finish it off like this. And when x is 2, y is 3. Nice easy one to start this topic. Another type of question where there's no squared in the two equations, but we can see that we have a product here. So there's a couple of ways to do this. You could identify that 3x has to be equal to xy, but that will only give you one solution, which we'll look at after we solve it. So if we could get y, we're going to, in the first equation, say that y, we bring it to the right, is equal to 3x plus 1. And then subbing that in here, you're going to get x times 3x plus 1. And then we're going to have minus y minus 3x plus 1. And I'll bring that 1 across. So you can see we're going to have a quadratic again. 3x squared plus x minus 3x minus 1 plus 1 is equal to 0. So you're going to get 3x squared minus 2x is equal to 0. And if we factorize this, we're going to get x times 3x minus 2 is equal to 0. So x is equal to 0, or x is equal to 2 over 3. And what y is equal to 3x plus 1. So y would be equal to, in this case, y would be equal to 1. 3 times 0 plus 1, or y is equal to 3 times 2 over 3 plus 1. So y will be equal to 3. So my two values are, when x is 0, y is 1. And when x is 2 over 3, y is 3. You may have spotted at the beginning that these two would have to be the same because the rest of the equations are the same. So you could say 3x is equal to xy. And you can see here, if x is equal, you could see a 0 solution here, possibly, or you might just see divide by x, so we get y is equal to 3. That will give me that solution there, but you may not have seen the 0 solution. So always substitute within these questions to get both solutions. So I'm going to give you one to do now. So pause this video and give this question a go. We should start with x is equal to 2y. Replacing my x's with 2y. I'm going to get 2y to be squared plus y squared minus 2 by 2y by y minus 9 equals 0. So we have 4y squared plus y squared minus, you can see here, minus 4y squared. So we've got cancellations. Minus 9 equals 0. So y squared minus 9 equals 0. So you should get y minus 3 by y plus 3, difference of two squares. So y is equal to 3 or minus 3. So x is equal to 2 times these values. So x is equal to 6 or minus 6. So when x is equal to 6, y is 3. And when x is equal to minus 6, y is equal to minus 3. So hopefully you've got this one right. I'm going to give you one more to do before we move on to the next lesson. So pause the video and try this one. Okay, so we can either sub in for x or y, and 3x is equal to 15 minus 5y. So we want x, and then we want x squared and minus 10x. X is equal to 15 minus 5y over 3. Now we're going to have two substitutions for x. If you did y, you'd only have one substitution, so may have been a bit easier to substitute for y, but it's the same answers we'll get, so it doesn't really matter. So x squared, square the top, 15 15s are 225. 15 by 5y is 75y, and it's minus 75y twice, so 150, and plus 25y squared over 3 squared, which is 9. So that's x squared. I'm going to have plus y squared, and I'm going to have minus 10x, so minus 10 times 15 minus 5y over 3, and I'm going to have a minus 9 equals 0. So I can multiply by 9. So I don't need this x squared here at the beginning. We were just saying what x squared was. So I can multiply by 9 to get rid of the denominator. So 225 minus 150y plus 25y squared plus 9y squared. And if I put a 9 here, I'm going to have 90 over 3. So I'm going to multiply this one by 30. So minus 30 by 15 minus 5y. And minus 9 by 9, 81 equals 0. So they do get a little bit tricky when you've got the fractions in them. So have I got my y squareds? I can get these two y squareds. So that's 34y squared. I'm going to have minus 150y. So take them off as you go, and there's a lot of terms. I'm going to have minus 30 by 15, and minus 30 by minus 5y is plus 150y. You can see here it simplifies for us. I've got the minus 30 by the minus 15. That's minus 450. I've got plus the 225. So I've taken in this one, and I've got minus 81 equals 0. So 34y squared. Tidying up the numbers, we have minus 225 minus 81. That will give me a minus 306. And you can see 340 divides by 34, so does 306. There'd be 9 of them. 10 would be 340. So divide by 34, and I got y squared minus 9. Sometimes they can work down to be really horrible quadratics in these questions. If you get one that doesn't look like it factorizes and it has weird numbers that are too big to simplify, just use the quadratic formula and get your answers that way. But in this case, it does simplify quite quickly. We're going to get y minus 3 by y plus 3. So y is equal to 3 or minus 3. And if y is equal to 3 or minus 3, x is 15 minus 5y over 3. X is 15 minus 5y over 3. So 15 minus 5 times 3, well, that's 0. Over 3, sorry, it's taking the 0 over, so that's 0. And 15 minus 5 by minus 3 over 3 is 15 plus 15, so 10. So when x is 0, y is 3. And when x is 10, y is minus 3. So practice a few more of these from your books and master solving simultaneous equations when there's one linear and one non-linear.